For decades, that patch of sky looked unremarkable. No bright stars, no obvious galaxies, just darkness. The kind of place you might skip without a second thought. Then, Hubble pointed directly at it. Not for minutes, not for a quick survey. It stared into that tiny section of apparently empty sky and kept collecting light. The expectation seemed simple. Empty sky should stay empty. Instead, the darkness began filling up. One galaxy appeared, then another, then dozens, then hundreds. By the time the observations were complete, thousands of galaxies had emerged from a region that had looked almost blank. The image did not reveal a new object. It revealed a problem with the map. A place that seemed finished suddenly became unexplored territory. What looked like empty space turned out to contain entire systems that had been hidden in plain sight. The consequence was difficult to ignore. If thousands of galaxies could be waiting inside a patch of sky trusted as empty, then darkness was no longer reliable evidence of absence. The assumption changed. Maybe the map was not nearly as complete as it seemed. And if one blank region could fail so completely, it raised an uncomfortable possibility. How many others were still waiting? The first image could have been dismissed as a lucky surprise, a hidden pocket of galaxies, an unusual corner of the sky, a rare exception. That explanation survived only until the process was repeated. Astronomers pointed deeper observations at other regions. Again, areas that appeared sparse began changing. What looked thin became crowded. What looked dark started filling with distant galaxies. The pattern kept returning. The procedure was simple. Look longer, collect more light, wait for details to emerge. Each time, the same thing happened. Structures appeared where very little seemed to exist before. That created a practical problem. A blank region could no longer be treated as a finished region. Darkness stopped functioning as reliable confirmation that nothing was there. Every apparently empty patch now carried uncertainty with it. The old assumption offered a useful shortcut. If a section of sky looked empty, attention could move elsewhere. That shortcut was disappearing. The map was no longer losing territory because galaxies were vanishing. It was losing certainty because new territory kept appearing inside places that already seemed understood. The deep field no longer looked like an isolated surprise. It looked like a warning. If repeated observations continued turning emptiness into population, then the question was no longer whether hidden regions existed. The question was how much of the unseen sky was still waiting for the same treatment. The obvious response was to build better tools. If hidden galaxies appeared when observations went deeper, then the frontier did not seem mysterious anymore. It seemed technical. Each upgrade sharpened the map. Regions that once looked sparse gained structure. Regions that seemed nearly empty revealed new populations. The boundary between known and unknown appeared to move outward every time the instruments improved. That made the situation look temporary. The missing territory did not seem permanently hidden. It seemed waiting. Waiting for larger mirrors. Waiting for longer observations. Waiting for technology capable of collecting details that older systems could not reach. The evidence appeared to support that conclusion. Better instruments repeatedly produced better maps. The process worked. The hidden galaxies were not staying hidden forever. For the first time, the problem looked manageable. Maybe the frontier existed only because previous generations lacked the right tools. Maybe every blank region would eventually give up its secrets if enough time and technology were applied to it. And if that was true, the future seemed straightforward. Keep improving the instruments. Keep pushing deeper. Eventually, the unknown should begin running out. For a while, the trend seemed obvious. Every improvement paid off. Better observations revealed more galaxies. Better maps revealed more structure. The frontier appeared to be shrinking. Then a strange pattern began to emerge. The discoveries were real. The maps genuinely became better. New structures appeared. Hidden populations came into view. But something else was happening at the same time. Each new observation did not simply fill in missing information. It pushed the visible boundary outward and exposed another layer beyond it. The frontier was not standing still while the survey caught up. It was moving. The deeper the survey went, the more unfinished the map became.
The frontier shifts.
A deeper look revealed more territory. Then beyond that territory, another region waited. The newly improved map immediately acquired a new edge. The process repeated again and again. Every dark region that filled with galaxies immediately exposed another dark region beyond it. The expectation had been straightforward. Eventually, the unknown should become small enough to finish. The gaps should narrow. The remaining territory should steadily decline. Instead, progress kept generating fresh territory to explore. The better the observations became, the farther the horizon appeared to extend. That did not mean the instruments were failing. They were working exactly as intended. The problem was that success and completion were no longer the same thing. A better map did not guarantee a finished map. A deeper survey did not guarantee the end of the survey. The frontier was still there after every improvement, which raised a more unsettling possibility. Maybe the frontier was not simply a technological problem waiting for a technological solution. Maybe something more fundamental was creating it. The pattern eventually became impossible to ignore. Every new observation pushed farther than the one before it. Every improved survey revealed additional territory. Every successful expansion of the map exposed another boundary waiting beyond it. The frontier never disappeared. Not because the instruments failed, because they worked. The moment a new region became visible, another limit appeared farther out. Access to information expanded, and with it, the edge of what could be explored. That changed the meaning of the frontier completely. It was not a gap waiting to be closed. Every time the map expanded, a new edge appeared with it. The moment one dark region filled with galaxies, another dark region took its place. The map grew larger. The known universe grew larger. But the lines separating known from unknown survived every victory. The expectation had been that progress would eventually finish the survey. Instead, progress kept creating a larger survey. The frontier remained alive because discovery remained alive. What looked like a temporary technical obstacle turned out to be part of the process itself. The map can grow. The known territory can grow. Entire populations of galaxies can move from unknown to known. But every expansion creates a new boundary. The frontier survives for the same reason exploration survives. Not because discovery fails, because discovery works. The frontier is not disappearing. It is moving with us.